Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set 4 of 5 good problems on the chapter of polygons. If you have not watched the previous 3 sets of 5 good problems solving on the chapter of polygons, then I highly suggest that you please also watch those videos to have a good practice of relatively harder problems. So this video is part of the playlist Maths 8 Hot, where Hot HOT stands for High Order Thinking, where I come up with relatively harder problems from every chapter as and when they are completed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, if you are visiting my channel for the first time, or if this is your first video and my videos are beneficial to you, then I strongly request and suggest that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 4 on the chapter of polygons. Okay, so I have the set of 5 problems, set of 5 good problems on the left hand side. I hope the fonts of the problems are looking big enough so that you can see them properly. The link to the PDF of these 5 good problems will be there in the description. You can check the PDF from there as well. But please note that always try to solve the problems yourself first. Only when after multiple attempts, if you are stuck, then you can refer this solution video. After solving a problem on the right hand side, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will be beneficial to you. Okay, so let's start solving the problems. Question number 1 says number of sides of polygons P1 and P2 are in the ratio 2 is to 3. If the sum of interior angles of both P1 and P2 together is 1980 degree, then how many diagonals P1 has? Now to know how many diagonals P1 has, definitely we have to find the number of sides of the polygon P1. Okay, the ratio of the number of sides of the two polygons are given to be 2 is to 3. Okay, so let number of, we assume based on the ratio, we assume the number of polygons of P1 and P2. Let number of sides of P1 and P2 be based on the ratio 2x and 3x respectively. Okay, now okay, so from the number of sides of a polygon, we know we can find the sum of the interior angles. So for P1, for the polygon P1, we can say that we know that the sum of the interior angles of an n-sided polygon is 180 multiplied by n minus 2. So for the polygon P1, we can say that 180 degree multiplied by 2x, since 2x and 3x, as per our assumption based on the ratio, are the number of sides of P1 and P2. So sum of interior angles of the polygon P1 will be 180 degree multiplied by 2x minus 2. This should be equal to 360 degree. Let this be result or equation 1. Again, for P2, for the polygon P2, applying the same concept of the sum of interior angles, we can say that 180 degree multiplied by 3x, since 3x is the number of sides of the polygon P2, this will be equal to 360 degree. Let this result or equation be 2. Okay, clearly we see that we have got okay. 2x 2x and 3x. if the sum of the interior angles of both P1 and P2 together is this. Two x and 3x. Now, okay, so I can see that from each individual equation only we can find x. We can find uh, from the equation 1, 361, 2. From equation 1, from this equation, I am wondering how do we use the information that the sum of the interior angles of both P1 and P2 together is 1980 degree. Anyway, so from equation 1 we can see that we will get 180 degree if we take 2 common, multiplied by 2, and then x minus 1 is equal to 360 degree. Simplifying the left hand side, we get 180 degree multiplied by 2 is 360 degree. 360 degree multiplied by x minus 1 is equal to 360 degree. If we ignore the degree, we get 360 multiplied by x minus 1 is equal to 360. We can cancel out 360 from both sides and we get x minus 1 is equal to 1. This implies x is equal to 1 plus 1, which is equal to 2. X is 2. Okay. If x is 2, then we can straight away we can get the number of sides of P1 and P2, because number of sides of P1 will be 2x, which will be 4, and the number of sides of P2 will be 3x, which will be 6. So this 2x will be 4 and 3x will be 6. And so if number of sides of P2 is 6, we can easily find the number of diagonals. But I am wondering why it is given that the sum of interior angles of both P1 and P2 is 1980 degree. We are not using that information. Anyway, let's see. So if okay, so we see that the number of sides of P2 is 6. So we can say we get that number of sides of P2 is equal to 6. Is equal to 6. Why? Because it will be equal to 3x, which is equal to 3 into 2, because x is found to be 2, which is equal to 6. So this implies number of diagonals of P2, we know the number of diagonals of a polygon of n sides is n into n minus 3 by 2. It will be 6 into 6 minus 3 divided by 2. This is equal to 3 into 3 equal to 9. So the polygon P2 will have 9 diagonals. So the answer is choice C. But it is strange that why the sum of the interior angles of both P1 and P2 taken together is given. It was not necessary to solve the problem. Anyway, so the answer is choice C. Okay, let's do the next problem. We have a figure. It says in this figure, side AB of polygon ABCD. We have a polygon ABCD. Let me roughly draw the given figure. So we have A, B, C, D. So we have this polygon A, B, C, D. Some angles are given. So this is given to be x degree. This angle B is 2x degree. Angle C is given to be 120 degree, angle D is given to be x degree. Okay, so all the internal angles of the polygon or quadrilateral ABCD is given. Only angle C is given as a absolute value, that is 120 degree, and the angle A, B and D are given in terms of unknown x. It is saying that the side AB is produced to point E, is produced to point E, okay, and definitely E and D is joined, okay. So this angle in the triangle AED, this angle is given as y degree, and this angle is given as z degree, and the ratio of y degree is to z degree is given as 2:1, okay. Or so it is given that y degree is to z degree is given to be equal to 2:1. This implies that y by z is equal to 2 by 1. We have to find the value of z, okay. Now first of all, definitely we will have to apply the angle sum property of a quadrilateral ABCD and possibly also the triangle AED. So in quadrilateral, by this square or rectangle, I mean a quadrilateral ABCD, applying the angle sum property, we will get x degree plus 2x degree plus 120 degree plus x degree should be equal to 360 degree. We know that for a polygon, for a convex polygon, the sum of we know that for a now why we know that for a polygon, actually this is about polygon. Now I have already covered the chapter of quadrilaterals in the other playlist, CBSE Maths 8 RS Agarwal, and so if you have seen the video on quadrilaterals, then you will know that the sum of the interior angles of a quadrilateral is 360 degree, because in general the sum of interior angles of a convex polygon with n sides is 180 degree multiplied by n minus 2, where n is the number of sides of the convex polygon. If you put for a quadrilateral, n is 4. In quadrilateral, when n is 4, it is a quadrilateral. So for, you can see that for n is equal to 4, as you can see in the ABCD is a quadrilateral. So for n equals to 4, for n equals to 4, this becomes 180 degree multiplied by 2. This is equal to 360 degree. So we know from the general formula of the sum of interior angles of an n-sided polygon is 180 degree multiplied by n minus 2, or from the formula properties of quadrilateral, that we know that the sum of the interior angles of a quadrilateral is always 360 degree. So we have this. Simplifying the left hand side, adding up all the x terms and taking the constant 120 degree on the right hand side, we get 4x degree is equal to 360 degree minus 120 degree. 360 degree minus 120 degree is 240 degree. So we have 4x degree is equal to 240 degree. If we ignore the degree, we get 4x is equal to 240. This implies x is equal to 240 divided by 4, which is 80. Okay, so x is 80. Now we have to find z, where the ratio of y and z is given. Now we also see that for triangle AED, we see that angle A is an exterior angle, and its two opposite interior angles are angle E and D. So we must have angle A is equal to angle E. Actually, in triangle, angle AED plus angle EDA, as these are interior opposite angles, interior opposite uh, angles to the exterior angle A. We have this. We know that in a triangle, an exterior angle is equal to the sum of its two opposite interior angles. So for the triangle AED, we have the angle A, the angle A of the quadrilateral ABCD is an exterior angle to the triangle AED, and its two interior opposite angles are angle AED and angle EDA. So this implies angle A we know is x degree is equal to angle AED is y degree and angle EDA is z degree. Okay. Now, if we ignore the degrees, we have x is equal to y plus z, and x we have already found to be 80. So we have y plus z is equal to 80, and we also know from the given ratio of y is to z that y by z is equal to 2 by 1. So from the concept of ratio and proportion, you know that if there are two quantities A and B, let's say A and B are two quantities, their ratio is given to be P is to Q, and also the sum of the two quantities is given to be, let's say, X, then we can find the individual value of the quantities. That is, A will be equal to P by P plus Q multiplied by X, and B will be equal to Q by P plus Q multiplied by X. I hope you are aware of this concept or result from the ratio and proportion. So applying this concept, we can say that Z, it is asking the value of Z. So Z will be equal to, now this is the given ratio was y is to Z is equal to 2 is to 1. So Z will be equal to 1 by 1 plus 2 whole multiplied by the y plus z, that is 80. This is equal to 80 80 by 3. 80 by 3. It is not coming to be an integer. Let me check if I did the calculation correct or not. The sum of the interior angles of quadrilateral ABCD is 360 degrees. So we have x degree plus 2x degree plus 120 degree is 360 degree. So we have 4x degree is equal to 360 degree minus 120 degree, which is 240 degree. So we have x is equal to 240 by 4, which is not 80, but this is 60. This is 60, and so we have this will be 60. This will be 60. This is 60. This is 60. So this is equal to 60 by 3, which is 20. So Z is 20. So this implies it is asking find the value of Z degree Z. So Z degree is equal to 20 degree. Even though in the choices, the given choices, the choices should be 30, 20, 45 and 40, because it is asking the value of Z. Z should not be in degree because Z is a value. In the diagram, it is already given the angle is Z degree. So Z will be a value number. So the choices, in the choices, it should have been, all the choices should have been 30, 20, 45 and 40. So anyway, so the angle Z is 20 degree. And the correct choice is B. B is the correct choice. Okay, let's do question number 3. The maximum number of acute angles a polygon can have is 2, 3, 4, 5. Now this is a conceptual problem. The maximum number of acute angles a polygon can have, it is not talking about, it is not talking about any particular any specific number of sides. In general, it is asking any polygon of any number of sides, what are the maximum number of acute angles it can have. Now, okay. Mm, Now, angles of a polygon means its interior angles. Now, we know that sum of sum of interior angles of n-sided, that is having n-sided polygon, n-sided convex polygon, n-sided convex polygon. In the problem, when it only says polygon, please always take it as a convex polygon. So, sum of interior angles of an n-sided convex polygon, we know the formula is 180 degree multiplied by n minus 2. Okay. Now, if this polygon having n sides need to have maximum number of acute angles, means an angle which is less than 90 but greater than 0. So, between 0 and 90 degree. Now, but also the sum of all the interior angles has to be equal to 180 degree multiplied by n minus 2. The maximum number of acute angles a polygon can have is maximum number of acute angles. Maximum number of acute angles. Now, the polygon with the least number of sides is triangle. In a triangle, for n equals to 3, we see that number of acute angles we know is equal to 3. No, number of acute angles, the maximum number of acute angles, if we consider the polygon of side 3, which is a triangle, what is the maximum number of acute angles a triangle can have? It is 3, because we can have it can be an equilateral triangle. All the angles of a triangle can be acute angles, like an equilateral triangle. So for n equals to 3, that is for a polygon of side 3, which is basically a triangle, the maximum number of acute angles is we can see is 3. Now, I am just trying to see what can be the maximum number of acute angles considering specific value of n, that is the number of sides. So for n equals to 4, which is a quadrilateral, what can be the maximum number of acute angles? For n equals to 4, the sum of interior angles, let me abbreviate the sum of interior angles as SOI. Okay. So for n equals to 4, SOI, that is the sum of interior angles, is equal to 180 degree multiplied by n minus 2, that is 4 minus 2. This is equal to 360 degree. So for a polygon of four sides, the sum of the interior angles is it will always be 360 degree. Now, in this since it has four sides, we will have four interior angles. So what will be the maximum number of acute angles? Maximum number of interior angles which are acute. So for n equals to 4, let's say in a polygon of side 4, there will be 4 angles. Let's say the polygon is ABCD. So we have the angle ABCD. So we will have angle A, angle B plus angle C plus angle D to be equal to 360 degree. Let's say this is the polygon A, B, C, D. with sides, number of sides 4. We know that the sum of the interior angles will be 360 degree. Now we have to find of the angles, of the 4 angles, angle A, B, C, D, what is the maximum number, what is the maximum, what is the maximum number of angles that can be acute. Okay, that can be acute. Now can that can be acute. Now please also note that for a convex polygon, each angle, interior angle, is also less than 180 degree. Is less than 180 degree. So is less than 180 degree. So if we consider, so in this polygon of in a quadrilateral, that is when n equals to 4, can we have, is it possible that we have already found that for a triangle, that is when n equals to 3, the maximum number of interior angles to be acute is 3. Now we have to look for whether we can find any other polygon of some side where the number of acute angles can be more than 3. So I am trying for quadrilateral, that is n equals to 4. I need to see whether all these angles, 4 angles A, B, C, D, can be acute. Now if that is the case, so if angle A, angle B, angle C, angle D are all acute. Acute angle means less than 90 degree and greater than 0 degree, of course. So this will imply that angle A will be less than 90 degree, angle B will be less than 90 degree, angle C will be less than 90 degree, angle D will be less than 90 degree. So if you consider these as 4 results, that angle A is less than 90 degree, even though this is a kind of inequality where we instead of equality sign we are having this less than sign. So this is kind of 4 inequality, even though you are not you may not be familiar with inequalities, solving inequalities. Let me briefly tell you that if we have this kind of inequality, so this is an equality where it is saying that x and y are 2 quantities, numbers, and it is saying that x is less than y. The value of x is less than value of y. Similarly, if we have, let's say, p and q, if p and q are other 2 numbers, and it is given that p less than q, so using these 2 results, given fact that x less than y and p less than q, we can add up these 2. That is, we can say that x plus p will be less than y plus q. We can say this. So I will apply this concept in these 4 in these 4 results, and I can say that angle A plus angle B plus angle C plus angle D will be less than 90 degree plus 90 degree plus 90 degree plus 90 degree. So this implies that angle A plus angle B plus angle C plus angle D is nothing but the sum of the interior angles of the polygon having number of sides 4. So I can say SOI is coming to be less than, on the right hand side we are having 4 times 90 degree, which is 360 degree, which cannot be the case. We know that for a polygon having 4 sides, the sum of interior angles is always equal to 360 degree as per the formula 180 degree multiplied by n minus 2. N for n will be 4, so we are having 360 degree. But if we consider that all the interior angles of a polygon of side 4 are acute, then we are having the sum of the interior angles is less than 360 degree, which cannot be which is not possible, because we know that the sum of interior angles has to be equal to 360 degree for n equals to 4. Okay, so it didn't work, so we could not find, so n will not work. N is not a solution. I mean, by solution I mean that for n equals to 4, it is not possible to have more than 3 interior angles which are acute. Okay, so we are targeting to find if there is any polygon of n sides where the number of interior angles which are acute is greater than 3. Okay, let's see. Let's see for n equals to 5. N equals to 5. For n equals to 5, what should be the sum of the interior angles? That is a convex polygon having the number of sides as 5. The sum of interior angles will be equal to 180 degree multiplied by 5 minus 2. This is 5. This is 540 degree. Okay. Now, so we are considering a polygon of side of number of side n equals to 5, and we are trying to see if this polygon can have more than 3 interior angles which are acute. So let's say, so n equals to 5 means this is a pentagon. So let's say the pentagon is this: A, B, C, D and E. So we have 5 interior angles. In the pentagon we have 5 interior angles. Okay. Now we need to see whether this pentagon can have um, 4 acute angles, 4 interior angles which are acute. So let's say, let angle so 4 angles we are considering. We are trying to see if this pentagon can have 4 interior angles as acute. So if 4 interior angles are acute, the fifth angle will be more than 90 degree. Will be more than 90 degree. Okay. So now, which angles to consider are acute in this pentagon ABCDE? We can consider any angle. So let's say angle, it does not matter. It does not matter. So let instead of taking particular angles, let's say let 4 interior angles. Let 4 interior angles of ABCDE, the polygon ABCDE, are acute, and let 4 interior angles of ABCD are acute, and let fifth angle be let's say x degree. The fifth angle be x degree. We do not know, but we are trying to see if 4 interior angles of this pentagon can be acute. So we are considering that 4 interior angles of this pentagon are acute, and the fifth angle we are considering as x degree. So we can say, okay, let these 4 interior angles, let's say be angle A, angle B, angle C, and let's say angle D. Angle D are the interior angles which are acute. It could be any other angles. It will not matter in solving the problem. You can consider some 4 interior angles of this pentagon are acute. Without any loss of generality, I can say that angle A, B, C and D are acute angles, and of course let's say are acute, and definitely and angle E is obtuse, that is greater than 90 degree. Okay. Now we must have, since the sum of the interior angles will be angle A, angle B, angle C, angle D, and plus angle E should be equal to 540 degree. Since we know that for our pentagon the sum of the interior angles is equal to 540 degree from the formula, using the formula 180 degree multiplied by n minus 2, where n is 5. Okay. Now this value, since all the angles A, B, C, D are all acute, that is less than 90 degree, uh, uh, we must have uh, one second. Okay, so now we have, since we have considered angle A, B, C, D to be acute and the angle E to be obtuse. So we have angle A is less than 90 degree, angle B is less than 90 degree, angle C is less than 90 degree, and angle D is less than 90 degree. Now if we add up just like before, if we add up all these four results, we can say that actually I should adding results 1, 2, 3, adding results 1, 2, 3 and 4 means in the inequality, that is something less than something, I am adding up all the LHS. So the sum of the LHS will be less than the sum of RHS. So we have angle A plus angle B plus angle C plus angle D should be less than 4 into 90 degree, because all the RHS are 90 degree. So this implies, so this is equal to 4 into 90 degree is 360 degree. So angle A plus angle B plus angle C plus D is 360 degree. Okay. Is less than 360 degree. But we also know that the sum of the interior angles has to be 540 degree. So we have angle A plus angle B plus angle C plus angle D is coming out to be less than 360 degree. Okay. So this implies that now we also must have angle A. We also must have angle A plus angle B plus angle C plus angle D plus angle E is equal to 540 degree. Is equal to 540 degree. Now from here we can say angle E will be equal to 540 degree minus, I am transposing all the angles A, B, C, D to the right hand side, and I have angle A plus angle B plus angle C plus angle D. Okay. Okay. Now this part, this angle, sum of angle A plus B plus C plus D is less than, we got is less than 360 degree. So I can say now that this will imply that angle E will be greater than 540 degree minus 360 degree. Why? if you have, let's say, if you have, let's say, x and y are two quantities, and we have, let's say, x is less than 10, and if you have, let's say, y is equal to, let's say, 100 minus x. So y and x are two variables, are two numbers, unknown numbers, and we have these two results. The first result is an inequality. It says that the value of x is less than 10, and the second one is an equation. It says y is equal to 100 minus x. Now, if y is equal to 100 minus x, so what we can say about the value of y when we know that the value of x is less than 10? If you put some values, let's say, if you let's say x and y are integers. Now x is, the value of x is less than 10, meaning it will have values like 9, 8, 9, 8, 7, like this. So the maximum value of x is 9. So if the maximum value of x is 9, then you can see that so when x is 9, x is less than 10, so x cannot have the value 10. X can start from 9. The value of x can be 9, 8, 7, 8, like that. When x is equal to 9, y is equal to 100 minus 9, which is equal to 91. Now when x is equal to 8, you will see that the value of y will be more than 91, because 100 minus 8 will be 92. So it will increase. So the minimum value of y is coming to be let's say, the minimum value of y will be 91, or we can say from here, from these two facts, that y will be greater than 91. Y will be greater than 90. See, if you keep on putting values of x, see, x is less than 10, so x can have values 9, 8, 7, 6, 5, 4, like this. If you keep on putting the values, you will see that the value of y will keep on increasing. And when x was 9, the value of y was 91. So it started from 91 and it kept on increasing. So we can say that the value of y is greater than 90. How come 90 is coming? It is coming from the fact that 100 minus 10, and why 10? Because it is given that x is less than 10. So applying this concept, we can say that in this we had this angle E is equal to 540 degree minus the sum of the angles ABCD, and we know that the sum of the angles ABCD is less than 360 degree. So we can say that angle E should be greater than 540 degree minus 360 degree. This implies angle E should be greater than 540 minus 360 is how much? 0, 8 and 1, 180 degree. So angle E is coming out to be 180 degree, which means that polygon E cannot, not possible. E cannot be more than, any interior angle in a convex polygon cannot be more than 180 degree. That is the definition of a convex polygon. In a convex polygon, all the interior angles are less than 180 degree. So we found that if four interior angles in a pentagon are acute, then we are coming to the result that the fifth angle is coming out to be greater than 180 degree, which is not possible. This implies This implies that four interior angles cannot be acute. So as you can see, if I keep on increasing, if I keep on checking for greater values of n, that is n equals to 6, n equals to 7, we will get the same results. So by this intuitive argument, I will say that the maximum number of interior angles in a polygon which are acute should be 3, which is in the case of a triangle, which is in the case of a triangle. So the correct choice is B. The correct choice is B. This was a little conceptual problem. I don't know whether I was able to properly give the justification that the maximum number of interior angles which are acute in a polygon will be 3. Okay. Let's see question number 4. The sum of angles of a concave quadrilateral is the sum of angles of a concave quadrilateral. Now, quadrilateral is a convex polygon having 4 sides. That is the definition of a quadrilateral. Now, a concave quadrilateral means that a concave polygon with 4 sides, something like this. So, a concave polygon means at least one interior angle will be more than 180 degree. So let's say we are having this. This is an interior angle. Let's say whatever this angle be. Let's say this is for the sake of discussion. This is let's say 200 degree. Let's say so. This is greater than 180 degree. Now we have these two sides. AB and BC are the two sides or rather the two arms which is making the interior angle greater than 180 degree. So it is talking about a quadrilateral. So we must have other two sides. So it should be something like this. 1, 2. Okay. So A, B, C, D. So this is a concave quadrilateral. Now it is asking what will be the sum of the angles, that is the sum of the interior angles of a quadrilateral. Now, if this is the case, so angle, let's say, let me draw it again. Let me draw the figure clearly. Let's say this is the concave quadrilateral. Let's say A, B, C, and D. Let's say this angle is A, this angle is C, this angle is D, and I hope this angle will be named after the vertex. This is angle P. Okay. Now let's give some names to the angles. Let's say angle A is let's say this is X degree, this is Y degree, and this is Z degree, and let's say angle B which is greater than 180 degree, because of which the quadrilateral is a concave. Let's say this angle B P degree. So we definitely have P greater than 180. Now it is asking about the sum of the angles. So sum of the angles, I am abbreviating sum of angles as SOI, will be in this as per the figure I have drawn, will be X plus Y plus Z plus P degree. Okay. The choices are 360 degree, greater than 360 degree, less than 360 degree, and 2 into 360 degree. 2 into 360 degree. The sum of angles of a concave quadrilateral. Okay. Now, I think we can possibly use the properties of triangle. Like if I, let's say, Okay, so if I join the vertices B and D, sorry, let me, I'm joining the vertices in B and D, and so we have two triangles. We are having two triangles ABC. We have now the entire concave quadrilateral has been divided by the segment. I think it's a BD is a diagonal, should be a diagonal of this quadrilateral. It's definitely B and D, the vertices B and D are opposite vertices, so BD must be a diagonal of this quadrilateral. So we are having, which is dividing, the diagonal BD is dividing the quadrilateral into two triangles, triangle ABD and triangle, let's say BCD. Okay, now, okay, now in triangle ABD, in triangle ABD. Now we know now why I am doing this kind of complex argument or calculation is that I know for a convex polygon, I know for a quadrilateral. Now in general, if you, a quadrilateral means a convex polygon with four sides, and I know that for a convex polygon with n number of sides, the sum of the interior angles is equal to 180 degree multiplied by n minus 2. I am not sure whether that formula works for concave polygon or not. So since this is talking about and so if it was, if it was only quadrilateral, definitely the sum of the internal angles of a quadrilateral is always 360 degree, because quadrilateral is nothing but a convex polygon with in four sides. So if we put n equals to 4 in the formula, 180 degree n minus 2, it will be 360 degree, but this is talking about concave quadrilateral. Okay, so now in triangle ABD, we must have the angle sum using the angle sum property. Angle A plus angle ADB plus angle ABD should be equal to 180 degree. So this implies that x degree plus uh, angle ADB plus angle ABD is equal to 180 degree. Okay. Again in triangle BCD, we must have using the angle sum property. You must have angle C plus angle CDB plus angle CBD should be equal to 180 degree. This implies angle C we have labeled as y degree, and we have angle CDB plus angle CBD is equal to 180 degree. Consider this result to be 1 and this equation or result to be 2. Now, if we add up these two results, adding 1 and 2, we get that x degree plus angle ADB plus angle ABD, this, that is, we add up the LHS of the two equation and equate that to the sum of the RHS of the two equation, plus y degree plus angle CDB plus angle CBD should be equal to 180 degree plus 180 degree, which is equal to 360 degree. Now, if we just rearrange a little bit the LHS, we get x degree plus y degree. Now, what is angle ADB? ADB plus angle CDB. So, if we angle ADB plus angle CDB, and we have angle ABD plus angle CBD, we are having equal to 360 degree. Now what is angle ADB plus CDB? Angle ADB plus angle CDB is equal to angle D. So we can say this is equal to angle x degree y degree plus angle D, and angle ABD plus CBD. ABD and CBD is angle B. B is equal to 360 degree. So we are having x degree plus y degree plus D is nothing but D was z degree. So essentially we are having the LHS as the sum of the interior angles is equal to 360 degree. So obviously we can see that the sum of the interior angles of a concave quadrilateral is 360 degree. So the correct choice is A. A is the correct choice. Okay, let's do question number 5. Okay, so a figure is given. The sides of a regular pentagon ABCDE are extended to produce a star having points PQRST. What is the measure of the angle? Angle P plus angle Q plus angle R plus angle S plus angle T. The sides of a regular pentagon. So let's say try to draw a regular. It is talking about a regular pentagon. Okay, so 5 sides. So 1, 2, 3, 4, 5. Okay, so this is a regular pentagon, and it is saying, let's say the pentagon is A, B, B, A, B, C, D, and E. Okay, so this is the given a regular pentagon. That is, all the interior angles are equal and also the sides are equal, having 5 sides. It is saying that all the sides are extended to produce a star. Okay, so if I extend the side AB, let's say over here, and I extend the side DE, they must intersect something like this. So this is point P. Similarly, we will have the diagram may not be perfect, but I hope you will get the idea. The sides are being extended and they are meeting at a point to produce the all the points of the star. So this is R. Similarly, if I extend CD and extends AE, so they are meeting at the point Q. So PQR are the points of the star. Also, we need to extend the side AB and extend the side CD to meet the point to create the point S of the star. And finally, if we extend the side BC and extend the side AE, they are meeting at the point T. So a star is formed where the corners of the star are P, Q, R, S, T. It is asking what is the value, the sum of the angles P, Q, R, S, and T. Okay. Okay. So what it is asking the value of the sum of the corner angles of the star. Fine. We know all these angles are equal. These are the interior angles of the pentagon. Let's say consider this angle to be x degree. We know that the sum of for for regular pentagon, for regular pentagon, we know the sum of the interior angles is equal to 180 degree. The formula is 180 degree multiplied by n minus 2 divided by n. So it will be 180 degree multiplied by 5 minus 2 divided by 5. This is equal to 30, 36 degree multiplied by 3, which is 108 degree. Okay. For regular pentagon, not SOI, sorry, not SOI, each interior angle, each interior angle will be 108 degree. So x is equal to 108. That is x degree is equal to 108 degree. Now, how do we find the angle, the sum of the angles PQRS? Now we can see that these are all triangles. These are all triangles that has been created. Now somehow we have to use the angle sum property of this. How many triangles are created? There are 5 triangles. Since there are 5 sides of a pentagon, 5 triangles has been created on each side. Okay. Also note that let's say also note that if you consider a particular triangle, if you consider, let's say, in triangle APE, in triangle APE, you can see that we have to apply the concept of the interior and exterior angle of a polygon. We can see that angle we must have x degree plus angle PAE should be equal to 180 degree. Since we know that in a polygon, an interior angle, the sum of an interior angle and its corresponding exterior angle is equal to 180 degree. So if you consider the angle A of the interior angle A of the polygon of the regular pentagon, we can say that x degree plus angle PAE, this angle is PAE. These two are the interior and the exterior angles for the regular pentagon at the vertex A. So their sum must be equal to 180 degree. Okay. So this will be same since it is a regular pentagon. This will be same for all the triangles. For all the triangles, that is the triangles formed at every side of the pentagon. Okay. Okay. Now in triangle APE, so this is actually this is not, this result is based on the x degree plus angle PAE is equal to 180 degree. This is a very fundamental property of lines and angles. If you extend, basically angle x degree and angle PAE are linear pair of angles, and so their sum should be equal to 180 degree. Okay. Now in triangle, so we have this. Oh, sorry, why I am doing so much calculation? We know x is x degree is x is 108, so x degree is 108 degree. So this from here we can say this is equal to from here we can say angle PAE is equal to 180 degree minus x degree, which is equal to x we have found to be 108 degree. So this is equal to how much? 72 degree. So angle PAE is 72 degree. Now since this is also x degree, we must have angle PEA. PEA should also be equal to will be again 180 degree minus 108 degree, because angle E of the pentagon and this angle are linear pair of angles, so their sum must be equal to 180 degree. So we must have angle PEA is equal plus x degree should be equal to 180 degree. So from there we get angle PEA is equal to 180 degree minus x degree. X degree is 108 degree. So this is also 72 degree. So as you can see that uh, angle in triangle APE we are having angle PAE is 72 degree and angle so these two are equal angle. These two are equal angle. These two are equal angle and it is 72 degree. Angle PEA and angle PAE is 72 degree. This will be same. Similarly, this will also be 72 degree. This will also be 72 degree. Similarly, this will also be 72 degree. This will also be 72 degree. This will be 72 degree and this will be 72 degree. Similarly, this will be 72 degree and this will be 72 degree. Since it is a regular pentagon, all the interior angles are equal. Okay. Now in triangle, in triangle APE, we know using the angle sum property, we must have angle P plus angle APE plus angle AEP must be equal to 180 degree. So this implies angle P, we know that angle APE and angle AEP both are 72 degree. 72 degree plus 72 degree should be equal to 180 degree. So this implies angle P is equal to 180 degree minus 2 times 72 degree, that is 144 degree, which is equal to 36 degree. So angle P is 36 degree and as you can see, since for all the other triangles, that is triangles EQD, DRC, CSB and triangle BTA, all the as you can see, all the similar angles, that is the angles which are adjacent to the interior angles are all 72 degrees. So we can say that based on the same logic, all the corner angles will be equal to 36 degree. So angle P, angle Q, angle R, angle S, they all will be equal to 36 degree. 36 degree. So we can now say that angle P plus angle Q plus angle R plus angle S plus angle T, since there are 5 corners, it will be 5 into 36 degree, which is equal to 180 degree. 180 degree. 180 degree. So the correct choice is C. C is the correct choice. Now there is there is a formula. If you have instead of this, there is a formula. If this was for a regular pentagon. Now for any regular polygon of n sides where n is greater than 4, as you can see that this will a star can only be formed. A star can only be formed when n is greater than for a polygon where n has to be greater than 3, greater than 4. Sorry, greater than 4. Even a regular polygon of 4 sides, which is a square, as you can see, you cannot produce the star. So it has to be n has to be greater, and also for a regular polygon of side 3, you cannot have a star. So the minimum value of n of a regular polygon where you can create a star is 5. So For any regular polygon, for any regular for any regular polygon of n sides the sum of angles, that is the sum of angles of the star, which is formed by extending the sides, the sum of angles of the star will be equal to n minus 4 multiplied by 180 degree. So for pentagon, if you put n equals to 5, you will get 180 degree. For hexagon, if you put n equals to 6, you will get 360 degree. And of course, the corner for a hexagon, the corner angles will be 72 degree. So this is a formula that you can remember, that for any regular pentagon, if you extend all the sides and create a star, then the sum of all the corner angles of the star will be equal to n minus 4 multiplied by 180 degree, where n is the number of sides of the regular polygon. With this, it comes to an end in solving the 5 good problems on the chapter of polygons. I hope these problems will give you a good practice of your understanding of the concepts of polygons, and will also evaluate your understanding of the chapter concepts. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will try to make more sets of 5 good problems on the chapter of polygons, even though I think I have covered up all the variants, all the possible variants. I will still try to come up with more problems on the polygons in the same playlist, that is Maths 8 Hard. So please stay tuned for more of these kind of problems, relatively harder problems, and very soon I will start the next chapter on parallelogram on the other playlist, that is CBSE Maths 8 RS Agarwal. I will end the video here. Thanks for watching, and until the next video, take care and bye.